Welcome to MS Research Australia's Research Report. I'm Dr. Hamish Campbell, and in this series we explore the research that's going on in Australia and around the world. In this episode, we meet Professor David Booth, who is looking at how the combination of someone's genetics and vitamin D may influence the risk of getting MS. This is what he had to say.
So at the moment, it looks like the way vitamin D is being used is not working. We know that from large clinical trials, and the effect on disease doesn't seem to have any effect on disease. The form of vitamin D that's being used is an inactive form, and in the body it's got to be activated in 2 steps. And we believe that in MS, because the activation is suboptimal, using inactive vitamin D is probably not going to be effective. But how do you find out if active vitamin D is better than inactive vitamin D? If you've got to wait for the results of clinical trials, it'll take too long before we know that information. So we need a more direct way to see whether the vitamin D is being activated and having an effect on immune cells in the body. So that's what our project is designed to do, devise a test to do that. In supplementation, it's normal to use inactive vitamin D. Inactive because it's safer. Inactive vitamin D is converted to active vitamin D by 2 steps. They're changing the molecule in 2 ways. And when you take the inactive form by mouth, it goes into the blood and the liver activates it, the first step. Then in the second step, the immune cell activates it. And it looks like taking inactive vitamin D, the first step done by the liver seems to be working. But the second step, where you're going to change in the immune cells, that doesn't appear to be working. Well, quite a lot, because firstly there's this phenomenon that the further you live from the equator, the more likely you are to get MS. This is called the latitude effect. And it doesn't matter if you live in South Africa, Australia, New Zealand, US, Canada, Europe, wherever of those places that you live, the further you live from the equator, meaning the less sunshine you get, the more likely you are to get MS. So sunshine is protective from MS. What sunshine does is produce vitamin D in the skin. That's our main way of getting vitamin D. Sunshine acts on molecules in the skin to make the precursor of vitamin D. So we know that the sunshine effect probably indicates the importance of vitamin D. The second thing we know is that if you take people all living with the same amount of sunshine, then the level of vitamin D in their blood still correlates with the risk of MS. If you haven't got enough, you're more likely to get MS. Thirdly, if you get immune cells and you treat them with vitamin D, they change their nature, so they become more protective and less reactive. So vitamin D looks like it works on the immune cells, and that's probably why it protects you from MS. And then the big thing, the thing that we work on, is the genetics. The genes which are involved in the activation of vitamin D are not turned on as much in MS as in normal people, so they don't activate vitamin D as much. And then the second thing is what vitamin D does is it turns other genes on. And the genes that vitamin D turns on, many of them are MS risk genes. So it looks like the action of vitamin D is very important in MS. So we're getting blood from people. Blood is full of immune cells. So we get the immune cells from blood, and then we treat them with active vitamin D or inactive vitamin D. And then we see whether the genes turn on or off by those 2 forms of vitamin D. So we start with controls because it's a normal process. And so you can see it very well in controls. Much easier to work on blood from controls. We just get it from people around the lab. And the next step is then we get the blood from people with MS and try the same thing. What we're expecting is that people with MS are not as responsive to vitamin D, both forms, inactive and active. But ultimately they still show the same pattern when you give them enough vitamin D. So we expect this test to be useful for everybody as a way of seeing what vitamin D is doing to their immune cells, but especially for the people with MS. So we actually have already done it in controls, and we know that it works in controls. We know that the genes which control vitamin D activation are affected by treating immune cells with vitamin D, and especially we know genes which were important in controlling immune cell function are affected by the two vitamin Ds differently. So we expect that it should be possible now to get blood from people with MS and do the same experiment. Well, in two ways. Firstly, immediately it's possible, because there are different forms of vitamin D available, to test those forms actually in clinical trials with this test to speed up the assessment of response. So to be able to show the different forms of vitamin D have different response. So that should be very quick to get into the clinic. The second thing is by showing the way vitamin D changes immune cell state, it's possible to use other methods to achieve that same change. And so the new therapeutic approaches could come from this. I think it'll benefit people from MS in two ways. One, by showing that the available forms of vitamin D can be used, which are better than the currently used form of vitamin D. And secondly, it'll show new ways to use the vitamin D pathway to protect people from MS.
Now that's a brief snapshot of Professor Booth's work. For more information, visit our website, like us on Facebook, and subscribe to our YouTube channel for future research reports. I'm Dr. Hamish Campbell, and I'll see you next time.